Hey everyone, today we're building a network engineering home lab in Cisco Packet Tracer. This lab will cover VLANs, inter-VLAN routing, DHCP, NAT, ACLs, and a few troubleshooting things. We have two PCs, a router, and a switch. Next, we're going to assign IP addresses. Each device needs a unique IP address, like giving them a home address. The router acts as a gateway, which allows PCs to send traffic outside their own network. On PC1, we will set the IP address that I just put in, and PC2 will be the same IP address. It'll be just .20. Later on, this will play a factor into what we're going to do with our VLANs. And then from there, we're going to now configure the router. We're going to configure the router 192.168.1.1 because that is the default gateway that we set for the two PCs. And to get there, we do enable for the console access, and then we do config T for the privileged access mode. And that allows us to make changes to the actual switch or router that we may be on. From there, we have to enter interface and then the port name that lets the device know I'm talking to that specific port. And then we're going to assign the IP address to that port along with the subnet mask. And then from there, I'm going to exit and go down to the console access mode or privilege. And then I'm going to use copy running config and startup config to save the configuration that we just did. Then we're going to go back and we're going to test it by pinging the default gateway, or you can ping the other PC. As you see, we did get connected to both, so we are on the right track. Now let's add VLANs. VLANs are separate device. VLANs separate devices into logic networks, and even if we're on, even if they're on the same switch. Sorry, thinking of it like driving a it's like dividing an office into departments like sales and IT. On the switch, we create VLAN 10 for sales, and we're going to create VLAN 20 for IT, and then we're going to assign PC1 to VLAN 10, and then assign PC2 to VLAN 20. So again, I like to change the name of my switch and router just in case you may have more than one router or switch. It's good to name them. From there, I'm going to create the VLAN by just typing VLAN 10, and then we're going to name that VLAN, the first VLAN 10. We're going to name that sales, and then for the second VLAN, VLAN 20, we're going to name that IT. From there, we're going to exit again, go down to the console access privilege, or we're going to exit to go back to config T, config terminal to assign those ports to those VLANs, because right now they don't have a port assigned to those VLANs. So that's what we're doing now. We're going to assign those ports by using switch port mode access and then switch port access and whatever VLAN it is, because we're still talking to that specific port. From there, we're going to now talk to the second port that PC2 is connected to. Do the same thing. We can press up to kind of shortcut it to the command that you just recently typed in. And we're going to assign the port 2 to VLAN 20. And now we have to trunk the ports to ensure that they are able to talk to each other. Because if you don't trunk it, those ports can't talk to each other or talk to the router to to um to to route the traffic to PC 1 and 2. Now I'm done with that. Now I'm gonna hit exit twice just to go down to the console access privilege. And I'm going to save the configurations just in case something goes wrong or use power or something happens. And now let's just check everything with show VLAN brief. This will show that we did create those two VLANs and we did assign those ports to those two specific VLANs. Now, VLANs can talk to each other by default, so we need to enter VLAN routing. We use a router on a stick configuration where one physical router interface handles multiple VLANs using sub interfaces. We create the port dot where the VLAN is for VLAN 10, and then the port dot the second VLAN for VLAN 20 with their own IP addresses. Then we can update the PCs. But let's go ahead and do this first. We're going to let them know which port or sub interface that we're talking to, which we're talking to VLAN 10 right now. We're going to encapsulate that VLAN 10 into its own virtual port, so that way it knows this is its own virtual port. Then we're going to assign it an IP address, and then we're also going to um, do VLAN 20 the exact same way. Now we're adding the IP address though. And now the PCs can communicate across the VLANs, just like the partners sharing information in a real company. Again, make sure you save. Now I just want to ping just to see if we can do it, if we can communicate across the network or across another VLAN. We should be able to do it, but I just want to check. Make sure you see request timed out. Now we have to go back, and now we have to statically assign this computer to that VLAN. We have to change the IP address and the default gateway to ensure that all matches up. We did it on PC 1, and now we're going to do it on PC 2. Double check that real quick. And now let's attempt to ping one more time just to ensure that we can't connect across the network. And there we go. We're able to connect across the network. And now let's configure DHCP. Mainly assigning IP addresses works, but DHCP automates the process. On the router, we will configure DHCP pool for VLAN 10 and VLAN 20 and exclude the router's IPs to prevent conflict. And then the PCs will be able to automatically get an IP address. So first, we're going to put IP DHCP exclude address. We're going to exclude the two addresses. I forgot a D in there. And then we're going to do the same thing. But for the other VLAN. And now we've done that. Now we want to create a pool of IP addresses for VLAN 10. A pool of IP addresses is just what IP addresses are available, IPs that a device can use if it's plugged into that network, that port for VLAN 10. So the network will be the network, the IP address of the network, and the subnet mask. And the next line with the default router, which is the default gateway of that VLAN. Which that IP address is for VLAN 20. Okay, corrected that. That's for VLAN 10. And now we want to do the same thing for VLAN 20. We want to exclude the IP addresses, or we're exclusive IP addresses. Now we're assigning the pools for VLAN 20. Which is the same thing. It's just we're changing the third octet to 20 instead of 10. Same subnet mask and also the default router, default gateway will be a 20.1 instead of 10.1. And now let's go ahead and test it. We're going to click DHCP and see if it gets a IP address, which it does. It checks out, it gets a correct IP address. And they want to check for PC2, do the same thing. And it was also was successful. So we did that correctly. Okay, next up are ACLs, access control lists. Think of them as a network bouncer. They allow or deny traffic based on rules. Here we're going to block VLAN 10 from accessing VLAN 20, but allow all of the traffic. ACLs are essential in real world networks to enforce security policies and protect sensitive departments. So here I'm using the command access list 100 deny this IP address with this subnet mask or anything in there. of a long one. This, if you are inputting this, just ensure that you are looking at those zeros. So there's a lot of zeros and dots in there. And then now we're going to permit any and any. And now we have denied VLAN 10 from accessing VLAN 20. And now that we've done that, as you can see, we have denied VLAN 10 for those, and then we also permitted VLAN 20 from any and any. And also by show IP DHCP binding, this allows us to see what devices are connected to us through those VLANs, or through DHCP that got a IP address through DHCP that we set up just a minute ago. Now I've got I've got a 0 in there. And now we simulate internet access using NAT. We connect the router to a cloud and configure NAT overload, which lets multiple internal devices share one public IP address. This is exactly how most home Wi-Fi routers work. NAT ensures internal devices can communicate with external networks safely and effectively. Okay. Yep, let's go overload wrong. There we go. Okay, so now that we've done that, we have completed this lab. Thank you so much for being here with me, completing this lab. I hope you, go along with me as I continue to build this lab, get more and more advanced. Please let me know anything I could do better or something that you want to see, and then we'll continue to get better together. Thank you so much for doing this, and have a good day.